we've built a robot here with a human-like form in order that it can experience the world in the same way that we can. This is our robot cog, which is where we eventually put pieces together. We're actively developing on smaller platforms because there's a lot of graduate students working on different aspects. We've all seen the cartoons of the person thinking, and inside their head is the little man looking at the screens of the stuff coming in from the eyes and controlling the levers and operating. Rather than having this whole top-down master planning of how I'm going to do things, the coupling happens out through the world.
There isn't any real central controller or single brain that runs everything. It's the interaction of all these individual pieces that gives us the interesting behavior. So to encourage people to interact with the robot naturally, we've built the robot to look like a human and to act like a human. Cog has 2 eyes, microphones for ears, and a set of gyroscopes that give it a sense of balance.
A lot of what goes on inside our heads when we're very young is learning how to coordinate our motions, our eyes, our ears, and everything out in the world. And we've got a lot of that sort of thing happening in this robot. And these are the fundamental social interactions which we believe lead to intelligence.
When an infant is first born, it has a very poor visual system. It has very poor resolution, but there are certain things that it can discriminate very easily. Things like motion and bright color. So those are the kind of capabilities that we're starting to build into Cog. So we want the robot's eyes to move in the same ways that the human eyes move. The most simple example of that is the saccade. It's a very rapid eye movement from one position to the other. So as I wave my hand, the robot will move its eyes and focus in on that target.
What you see here is the camera, Cog's camera, and the boxes are being drawn around where there's perceived motion in the scene. And this motion information is sent to a second routine, which has learned previously how to move the eyes to focus onto any target. And when it gets that data, then it ends up moving the eyes to focus on Brian's moving hand.
So my area of specialty is the arms of Cog. And in keeping with the rest of the project, instead of trying to program the arms explicitly so that I explicitly tell the arms what they should do, I've been trying to program the arms so that they respond to their environment and interact with their environment. I have the oscillators at these 2 joints here, and they're getting feedback about how the weight of the slinky goes from arm to arm, and they're using that to coordinate the 2 joints. And because the system is reactive, and I can stop this thing, and when I let go, it will straight away start again into the right slinky action.
Human infants learn not as if they're in a complete vacuum. They really learn a lot from their parents, their caretakers, the people that they interact with.
And a lot of the early communication that infants learn is strongly based in emotions and motivations. And that's how I started pursuing that line with this robot. This is a Kismet. Kismet's my infant robot. It gives me facial expressions, which tells me what its motivational state is. This one is interest. This one is sadness. This one is surprise. This one is tired. This one is sleep. And that's my cue to back off, meaning that it's really tired, I better just let it sleep. It has drives, it has an agenda it's trying to satisfy, much like how an infant has drives it must satisfy. And what it learns and how it learns is strongly biased by, are those drives being met? And me, being the caretaker, being very receptive to reading these emotional cues and responding to them in the way I interact with the robot to promote its learning. Eventually, I would actually like to give it a face and to make it look kind of very appealing, so anyone coming off the street would automatically want to fall in this kind of nurturing role and helping the infant learn over time.
A human grows from little tiny to great big. The whole structure changes over time, and as we've learned how to build the robot better, our robots change, and our programs, since they're built that way, have adapted to the changes. So in principle, I see no reason that we can't build a robot eventually, maybe not in my lifetime, that is as capable as a human being.